How did the most advanced airliner of its time, one that could literally land itself in zero visibility, end up as one of aviation's biggest commercial failures? This is the story of the Lockheed L-1011 Tristar, a jet pilots adored but airlines abandoned. Born in a high-stakes race against McDonnell Douglas's DC-10 and Boeing 747, the Tristar promised to put Lockheed back on top of commercial aviation, but instead it triggered a chain of events that would ultimately change the commercial aviation industry forever. The story starts back in 1968, where Lockheed faced significant challenges in commercial aviation. The company hadn't built a successful commercial airliner since the L-188 Electra turborop in the 1950s. While the Electra eventually operated successfully after modifications to address wing vibration issues with around 170 units sold, it had faced fatal crashes that damaged Lockheed's commercial repute. Its standing in commercial aviation needed rebuilding and quickly. Boeing had just launched the massive 747, and airlines were demanding something different. They needed an aircraft that could carry 250 to 300 passengers on medium to long-haul routes without the 747's enormous capacity and operating costs. American Airlines approached manufacturers with specific requirements. Both Lockheed and McDonnell Douglas were listening intently. This was Lockheed's opportunity for redemption. They assembled their best engineers in California with one clear mission: create the most advanced airliner the world had ever seen. The L-1011 Tristar would be their answer. While McDonnell Douglas was developing its competing DC-10 with conventional approaches, Lockheed introduced groundbreaking technology that outpaced contemporary aircraft. Let's start with the S-duct, probably the most elegant engineering solution you've never heard of. The DC-10 mounted its third engine directly on top of the fuselage. Simple, straightforward, conventional. Lockheed engineered an S-shaped duct that fed air from an intake at the base of the vertical stabilizer down through a curved path to an engine buried deep in the tail. This wasn't just showing off. The S-duct provided cleaner airflow with less turbulence, reduced drag, and actually made the aircraft lighter than conventional tail engine mounts. The engineering precision was remarkable. Lockheed kept the curve of the duct to less than a quarter of the radius of the engine intake diameter that maintained nearly straight-through engine performance despite the complex path. But this was just the start of the real innovation. The Avionic Flight Control System, AFCS, significantly outperformed contemporary aircraft. Remember, this was the early 1970s. Most people had never seen a computer. The internet didn't exist. Calculators were cutting-edge technology. Yet, the L-1011 featured what was essentially early fly-by-wire technology for its elevator controls, speed management systems, direct lift control, and an advanced inertial navigation system. All these systems communicated with each other, creating a level of automation that wouldn't become standard industry-wide until the 1990s. The AFCS featured automatic thrust management that maintained precise speeds during approach and climb. Direct lift control used spoilers to make minute adjustments to descend rate without changing the aircraft's nose attitude. The flight director system could guide pilots through complex procedures with unprecedented precision. And then came the key innovation. The L-1011 became the first widebody aircraft to receive FAA certification for Category IIIB Autoland capability in 1972. While the narrow-body Hawker-Siddeley Trident had earlier achieved Category IIIA certification, the Tristar's achievement for widebody aircraft was groundbreaking. What does that actually mean? It could land completely automatically in visibility so poor that human pilots couldn't even see the runway. Dense fog, heavy snow, conditions that grounded every other aircraft. We're talking runway visual range as low as 150 feet. The aircraft could find the runway, align itself, touch down, and even steer itself down the center line after landing, all without any pilot input whatsoever. The system relied on 3 autopilot computers for redundancy, dual ILS receivers for inch-level precision, and automatic adjustments to power and control surfaces for flawless touchdowns, often more consistent than human pilots. Lockheed had made one crucial decision that would ultimately destroy the entire program. It offered only one engine option, the Rolls-Royce RB211. On paper, this wasn't necessarily bad. Rolls-Royce was promising a revolutionary new engine with advanced technology and exceptional fuel efficiency, but it meant Lockheed was betting the entire future of the L-1011 on a single supplier. The RB211 was supposed to be Rolls-Royce's breakthrough, a high-bypass turbine with advanced materials and cutting-edge design. However, developing new technology proved prohibitively costly, and Rolls-Royce was burning through money at an alarming rate. The problems ran deeper than just cost overruns. Rolls-Royce had promised revolutionary carbon fiber fan blades that would be lighter and more efficient than traditional metal ones. During testing, these blades failed catastrophically, becoming unreliable when they ingested birds or encountered severe weather. The company was forced to completely redesign the engine with heavier titanium blades, driving up costs and delaying development by months. Meanwhile, Rolls-Royce had locked themselves into fixed-price contracts with Lockheed, meaning it had to absorb all these additional costs themselves. Then, in February 1971, disaster struck. Rolls-Royce declared bankruptcy. The massive development costs of the RB211 had literally destroyed one of Britain's most famous engineering companies. Production was severely disrupted. Though work continued under government oversight, Lockheed's situation became critical due to the delays and mounting costs. They were spending more on the L-1011 program than they were earning. And with limited sales prospects, they couldn't reach the economies of scale needed for profitability. Lockheed investigated switching to American engines, General Electric or Pratt & Whitney, but it was too late. The L-1011's engineering was finalized around the RB211. That elegant S-duct was specifically designed for the RB211's dimensions and airflow characteristics. Changing engines, it would mean having to redesign the entire back half of the aircraft, adding years to development and hundreds of millions to costs it couldn't afford. The British government, recognizing that Rolls-Royce was too big to fail, stepped in and nationalized the company. It committed to continuing the RB211 program, but the damage was done. The L-1011 program was delayed by over a year, while Rolls-Royce sorted out their mess. Service entry was pushed to 1972, months after the DC-10. In the fast-moving world of commercial aviation, a year delay proved devastating. While Lockheed waited for the L-1011's engines, McDonnell Douglas was completing development of their DC-10 and delivering aircraft to customers. Airlines desperate for new wide-body jets just couldn't wait for the delayed Tristar. So many turned to the DC-10 instead. Even so, some carriers put their faith in Lockheed's aircraft. Eastern Airlines, TWWA, and Delta were among the first to place orders, later joined by Cathay Pacific, British Airways, and All Nippon Airways. At first, the DC-10's head start seemed decisive, but while the Tristar struggled to attract customers, the DC-10 would later be plagued by catastrophic safety failures that shattered its reputation. The Tristar, caught between weak sales and the fallout from its rival's crisis, was dragged into a cascade of problems that ultimately sealed its fate. First was market timing. By the time the Tristar entered service in 1972, the DC-10 had already captured significant market share. Airlines hate mixed fleets. It's expensive to maintain, train crews for, and stock parts for multiple aircraft types. Once an airline was committed to the DC-10, they were unlikely to also buy L-1011s. But worse was coming. The 1973 oil crisis sent fuel prices skyrocketing and triggered a global recession. Airlines that had been eager to expand their fleets suddenly found themselves cutting routes and deferring aircraft deliveries. The market for new wide-body aircraft collapsed just as the L-1011 was trying to establish itself. The U.S. government watched nervously as one of America's premier aerospace companies teetered on the edge of bankruptcy. Lockheed employed tens of thousands of Americans and was crucial to national defense programs. In a controversial move, Congress approved a $250 million loan guarantee to keep Lockheed afloat. The congressional hearings revealed the full extent of Lockheed's problems. They'd committed to selling L-1011s at prices that assumed they would build around 350 aircraft for break-even. But with delays mounting and sales lagging, those assumptions were proving disastrously wrong. Every aircraft it had delivered was actually losing money. Opposition to the loan guarantee was fierce. Critics argued that if Lockheed had made bad business decisions, taxpayers shouldn't bail it out. This government intervention made Lockheed politically toxic in some circles. Some potential customers became wary of associating with Lockheed, fearing political backlash. Looking back, several strategic decisions sealed the L-1011's fate beyond just the engine crisis. The single-engine option was a critical mistake. By offering only the RB211, Lockheed gave airlines no alternatives if Rolls-Royce had problems. The DC-10, by contrast, could be ordered with engines from General Electric or Pratt & Whitney. This gave airlines choices and negotiating leverage. Lockheed also underestimated the importance of a global sales network. Boeing and McDonnell Douglas had decades of experience selling to airlines worldwide, with established relationships and support infrastructure. Lockheed was essentially starting from scratch, trying to convince foreign airlines to trust a company that had been absent from commercial aviation for over a decade. Its military-focused corporate culture struggled with the commercial aviation world's emphasis on cost control, operational flexibility, and life cycle support. By the late 1970s, it was clear that the L-1011 program was in terminal decline. Total sales struggled to reach 250 aircraft, significantly below what Lockheed needed for profitability. Lower production volumes meant higher per-unit costs, making the Tristar even less competitive on price. It was a vicious cycle. Higher prices led to fewer sales, which led to higher prices, which led to even fewer sales. International sales were particularly disappointing. Key markets like Europe and Asia went overwhelmingly to the DC-10 and later the Airbus A300. The emerging Airbus consortium was particularly aggressive in targeting international consumers, offering attractive financing packages and technological transfer deals that Lockheed simply couldn't match. By 1981, the writing was on the wall. Lockheed announced they would end L-1011 production, delivering the final aircraft in 1983. Total production just 250 aircraft over the program span from 1968 to 1984. The L-1011's failure led to significant layoffs at Lockheed, with thousands of skilled engineers and workers losing jobs by the mid-1980s. This downsizing weakened Lockheed's commercial aviation expertise, forcing a pivot to military contracts. It highlights the human cost of the program's collapse. For comparison, the DC-10 sold 446 aircraft, including KC-10 tankers. Boeing's competing 767 would eventually sell over 300. The L-1011's failure marked the end of Lockheed's commercial aviation ambitions. The company decided to focus entirely on military aircraft and defensive contracts. With Lockheed out of the commercial market, the industry began a long consolidation that would eventually leave just two major players, Boeing and Airbus. The L-1011's failure eliminated what could have been a strong third competitor. So, what happened to all that advanced technology that made the L-1011 so special? The Autoland systems and fly-by-wire innovations pioneered on the Tristar eventually found their way into later aircraft. Boeing and Airbus aircraft families incorporated many concepts first proven on the L-1011. The sophisticated flight management and diagnostic systems became standard across the industry. The Tristar was a preview of where commercial aviation was heading. It was just 20 years too early. The Rolls-Royce RB211 engine, despite nearly killing both companies, survived and even thrived. The technology developed for the RB211 evolved into the Trend engine family, which powers many of today's most advanced aircraft, including Boeing 777s and the Airbus A380. The L-1011's early retirement from most passenger fleets led to some fascinating second careers. NASA used one L-1011 for research programs. The Royal Air Force operated 9 aircraft as tankers and transports into the 2000s. Most famously, Orbital Sciences converted an L-1011 into a Stargazer, a flying launch platform that carried rockets to high altitude for satellite launches. The Tristar's smooth ride and advanced systems made it perfect for these specialized roles. Among aviation enthusiasts, the L-1011 achieved cult status. Pilots and airlines praised the L-1011 for its advanced cockpit ergonomics and passenger comfort, with features like larger windows and quieter cabins setting it apart from competitors. Eastern Airlines, a major operator, noted its reliability once initial issues were resolved. This feedback underscores why the aircraft gained a cult following despite its commercial failure. Pilots who flew it consistently rank it among the best aircraft ever built. Passengers remember it as exceptionally quiet and comfortable. Engineers admire its elegant solutions to complex problems. The Tristar represented everything Lockheed did well: innovative design, superb engineering, and uncompromising quality. The L-1011's failure echoed far beyond Lockheed's balance sheets. By bowing out of commercial aviation, the company paved the way for Boeing's rise to market dominance. Analysts suggest that a thriving Tristar line might have altered the industry's trajectory, creating a more dynamic landscape with additional choices for airliners and fiercer innovation. With Lockheed retiring and the DC-10's reputation collapsing, neither contender survived. What could have been a three-way race for decades instead narrowed to just Boeing, and soon after Airbus. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?